Okay, hello everyone. So today I just solved the review question, and if you have any question, I will answer it. So okay, so do you have any other question before starting this? Okay, then let's start the number one first. So yeah, in number one we have preference list. A, B, C, A, C, B. Oh, I just write down it below. A, C, B, BCA, BAC, CBA, and CAB. And each one has 10, 1, 5, 3, 8, 2 boards. Then first question is to use the board table above, sorry, it's not below, above, to determine the winner using each method. If there is no winner, then write DNE. So it actually consists of all voting process we learned in the chapter. So first one we can see is about priority voting, right? So in case of priority voting, then what you need to do is just check the number of votes who takes some candidate as your first preference or first rank, right? So for example, A is chosen by this ABC and ACB preference. So A got 10 plus 1, 11 votes. And B was chosen by people in the second one. So B got 5 and 3 votes, so 8 votes. And C was chosen by these people in the CBA and CAB. So it should be 10,
B is
right?
the plurality winner.
Pardon? Do you have any question? Yes, so it is about the priority winner. So in this case, A got the the most votes among all other candidates, so A wins, right? And next one, pardon? And next one is about the majority rule or majority voting. So in case of majority voting, everything is the same as priority voting, right? But in this case, majority voting means that winner should get at least half of the votes. So in this case, A got 11 points, but total votes is actually 11 plus 8 plus 10, which is 29, right? But 11 over 29 is definitely less than 50% because 50% of 29 is just 14.5, right? But 11 is less than 14.5. So in case of majority voting, there are no winners. Do you have any question on this priority voting and majority voting?
I'm sorry, I missed this earlier from question 1. It's winner of plurality was I put ABC and it was wrong.
Yes, so, okay, so in the winner of priority, what you need to do is just check how many people think that the candidate is the first rank. So in case of A, there are 11 people thinks that A is the first rank. And in case of B, there are 8 people thinks that B is the first rank. And in case of C, there are 10 people thinks that C is the first rank. So that's why A got 11 votes, B got 8 votes, and C got 10 votes. So A wins because vote for A is, the most among all other candidates, right?
Got it.
Does it make sense, Xavier?
Yes. Sorry, I thought it was the sets of 3
Okay.
letters.
Oh, yes. So if this 3 letter means that A is
Yeah.
preferred to B and B is preferred to C. So it is kind of the list of the ranks for each candidate.
Got it.
Okay, great. Okay. Do you have any other question?
So for the majority voting, half, wouldn't it be half plus 1? Like if anybody did have any votes, it'd be plus 1, right? Or is it just half?
So it should be greater than half. So in this case, if anyone got 15 points, then he wins.
Okay.
But there are only one case that even if the two candidates are helpful voting, but he didn't win. So it is kind of case that there are 30 people and A got 50 points and B also got 15 points. Then in that case, there are no winners, right? But except of that kind of case, so for example, if A got 15 points and B got 7, C got A, in this case, A wins in majority voting. So that's the special case.
Okay, thanks.
Thank you, Miriam. Okay. Do you have any other question? Okay, so one thing I just want you to know is that in case of those two kind of, priority voting and majority rule, then you don't actually need preference risk, right? Which means that even if you don't know that which people prefer which, if you just know about the who wants to the first rank of people's mind, then you are fine. You don't need to get the full kind of ranks for each alternatives for each candidate, right? So just need first rank is fine, right? So in these two cases, you don't need such a preference risk. So that's one comment for exam. And next one, now we wanna do same thing on contrast method. So in case of contrast method, what you need to do is just compare each alternatives in 1-to-1. So for example, in case of A versus B, then you can see that ABC, people in ABC means that they prefer A to B, and people in ACB means that they prefer also A to B, and people in BCA, however, prefer B to A because B is the first rank, but A is in the last rank. And people in the BAC also prefer B to A. And people in the CBA also prefer B to, and people in the CAB prefer A to B. Right? So in this case, 10, 11, 13, so 13 people prefer A to B, but 5, 3, 8, and 16 people, yeah. prefer B to A, right? So the answer purpose, third question, vote for A greater than B is 13, but vote for B greater than A is 16. So it means that B actually wins A, right? Do you have any question? Okay, likewise, you can do this for C to B, right? So instead of A to B, you can do this for C to B because B wins A. So if B also wins C, then B is the condenser winner. So then from, I don't want to do this. Okay. So from the first one, A, B, C means that A is preferred to C. No, B is preferred to C. So it is B to C. And in the ACB, it means that C is preferred to B. And from BCA, B is preferred to C. And in the BAC, they prefer B to C. And in the CBA and CAB, C is the first rank, which is definitely greater than B. So in that case, there are 10, 5, and 3%, 10 plus 5 plus 3, which is 18 people prefer B to C. And for other 1, 8, 2, which means 1 plus 8 plus 2, 11 people think that C is greater than B. So from this, we know that B wins C again, right? So in the Weber-Stein program, the vote for C greater than B means 11 as your answer, and vote for C is less than B means 18 as your answer. So, and from this, you can see that B wins A and B also wins C. So B wins any other candidate. So therefore, winner from the control method is B. Do you have any question? Oh, okay, Grace questions that why do we not need to find the relationship between A and C to find our answer? Because in this case, in the Condorcet method, winner is the candidate who wins every other candidate in 1-to-1, right? But in this case, actually B beats A and C both, right? If B is beaten by C, then we need to find the relationship between A and C because we need to get conclusion whether C beats A, so there is a winner is C, or where A also beats C, so in that case there are no winner in the Condorcet method, right? But in this case, from these two calculations, we know that B wins A and B also wins C, so you don't need to find relationship between A and C. Does it make sense, Grace? And Lindsay question that will the task be set up this way, like the review, with the same risk but using different methods, or will there be a different risk for each? Unfortunately, yeah, will there be different risk for each? Because that's what department wants. So there are several different cases, right? I will give you some different preference risks for each cases. And you need to find the control semester winner or priority winner or majority winner or any other winner in some specified procedure. So that's why you have 2 hours in this case, and also 30 programs are there. But the reason I put everything in one example is that I just want you to compare each method and difference, because, for example, priority voting is very, very similar to the majority voting. So a lot of students actually have some confusion on applying one of the rules. So that's why I put it everything in the one example so that you can compare each method, right? Does it answer your question, Rinji? No, yeah, in case of you choose the Zoom Plus paper proctoring, then what you need to do is just taking a picture during the time your camera on and send it to me. So yeah, and you don't need to change it into the PDF file. You can just send your image file in your camera, in your cell phone directly to me using your email. So I think that will not that much worried about you. So, and don't worry too much about the rate, because just explain what happens to you. then I definitely do not count it as well until you didn't do any academic dishonesty. Yeah. Okay. Oh yes, you can use the computer paper, but in that case, you need to show your computer paper on your camera. So it should be recorded. If it is not recorded, then it may be trouble. Okay. Okay, so do you have any other question on this control semester? Okay, then let's go to the board account. So in the board account, what you need to do is just press rank. So if there are n candidates here, n is some number, then first rank got n-1 point, and second rank got n-2 points. So n-1 rank got 1 point, and nth rank, which is just the last rank, we get 0 point, right? So just count each of the rank status of each candidate and give some preference numbers. So, okay, let's deal with CBA, CAB, so 10, 1, 5, 3, 8, 2. So in this case, for A, those first two preference reads thinks that A is in the first rank, right? So A got 11 votes as first rank. And there are two cases, two preferences case that thinks that A is in the second rank. So 5 votes, 3 plus 2 is 5. So 5 votes as second rank. And the last two cases, the remaining two cases thinks that A is in the last one. So 13 votes as third rank. So this 11 votes got 2 points because here n is 3, right? There are 3 candidates. And these 5 votes we got 5 points. And these 13 votes got 0 point. So what I get is 11 times 2, plus 5 times 2, 32 points, right? So that's what actually I got in this board account. And likewise, you can do the same thing on B. Okay, so in these two cases, B will get 8 votes as first rank, And in these two cases, 18 votes as second rank. And the other remaining two cases, he got 3 votes as third rank. So what we will get is 8 times 2 plus 18 times 1, which is 16 plus 18. So I didn't, oh, thank you, Catherine. Yeah, it should be changed to 1. Oh, that's typo. Thank you. Yeah, it should be 5, so 27. Yes. Yes, thank you, Catherine and Rinji. Yeah, so A should get 27 points instead of 32. And in case of B, it should get 34 points in total. And in case of C, okay, I just changed some colors. So these last two case thinks that C gets the first rank. So 10 votes will think that she got the first rank. So you need to multiply 10 with 2 plus this one, and this one thinks that C is as your second rank. So these are from 6 points. So if you just adding those two, then you got 26. And did you add the 10 and 1 from A? So yes, so this 11 votes came from this 10 plus 1. And these 5 votes came from this 3 plus 2. Okay, great. So in case of C, you got 26 because yeah, this A plus 2 gives you 10 votes on first rank, and 1 plus 5 gives you 6 votes on the second rank, and other 10 plus 3 votes, which is just third rank on C, so you don't need to count it. Then if you compare all those points, then B got the most points on the border count. So the winner from the border count is the Okay, so if you have no question, then I will go to the health system. So in case to do is just first of all do the same thing on priority. Oh, sorry, my internet is not that stable. Okay, can you see it again, or can you see my screen now? Okay, great, thank you. When Pura says that with the border count, will you have to continue calculating until you get the candidate with measure bit? No, in case of border count, after you got all the points, then you can just apply the priority vote, then you are done. So for example, in this case, B point is definitely not the majority, right? If you add all those points, then definitely 34 is not the half of the all possible points, but still B is win. So in that case, you don't need to apply, after calculating all the points, then please apply the priority rule, not the majority rule. Great. Exactly how do you divide the votes for each place? Like why those seconds get -2 here? Where should I get -2? This, you mean? Oh, so here it is n-2. So n is the number of candidates. Yes, what Catherine says that, yeah. So here in our example, we have 3 candidates, A, B, C, right? So that's why I give it 2 points, which is 3 minus 1 is 2 for first rank, and 1 point, which is 3 minus 2, which is the second rank, and so on. But for example, if we have 5 candidates, then the first rank will get 4 points, which is 5 minus 1 is just 4. And second rank will get 3 points because 5 minus 2 is 3. Does it make sense? Okay. Good. No, actually, yeah, as you can see in the example, there are some question about question the what point of A in board account or something like that, right? So definitely in the exam, you will see such a problems, right? Not only asking you who is the winner, but also asking you who got how many votes or how many points in some specific voting method. Okay, do you have any other question? Okay, great. Then let's deal with hair system. So, there are another question. Will we give given table like in the example from the notes? Yes, you will have a table. So you will have set table like this preference list, like this. Yes, you will definitely get this kind of table. Then what you need to do is just, counting how many votes the candidate get from some specific method, or who is the winner in specific method, or so on. Okay, then let's go to the hair system. So hair system is kind of, sequential priority vote. So in the first round, do the priority voting, but instead of, picking the winner who got the most votes, just put the candidate who got the purest vote and delete it. Then you can do the priority voting again, then got the winner, right? So that's the hair system. So in this case, we know that from the priority voting, we know that A got 11 points, B got 8 points, and C got 10 points, right? So in the round 1, everybody is alive. So A got 11 points, and B got 8 points. C got, how many got C? Oh, 10 points, sorry, 10 points. So here, that's what voting votes for round 1 votes for A, B, and C in hair system. So from this, B should be eliminated because candidate who has the purest vote is B, right? And then what you need to do is actually what we given is here, right? A, B, C, A, B, C, A, B, A, C, and CBA, CAB. But here, what you need to do is just deleting this eliminated one, right? And then what you have is AC, which means that it is just A prefers C. prefer A to C, and another AC, it also means that A just prefer C, prefer A to C, and CA means that they prefer C to A. So there are 5 people think that prefer C to A, and another AC, there are 3 persons think that A is just preferable to C, and CA and CA 8 and 2. So here, those who prefer A to C are only 10 plus 1 plus 3, which is 14 people. And those who prefer C to A is 5 plus 8 plus 2. So we think that A is prefer C, and 5 plus 8 plus 2, which is 15 people thinks that C prefer A. So in this case, you can guess actually C is the winner in majority rule, right? Or in plurality rule. So in case of Hare system, after eliminating all possible candidates, then what you need to get is only 2 candidates. And among 2 candidates, if you do the plurality voting, then it is the same as majority voting, because in voting with 2 candidates, if someone got more votes than the other candidate, then they will definitely got more than 50 points. So in that case, you can see that C is the winner, right? So in the web assigned question, round 2 votes for A should be 14, but round 2 votes for B should be D and E, because B is eliminated, and round 2 votes for C should be 15. And winner from the Hare system is C, because C actually got the, C actually beats the A. Right. Okay. Do you have any question on Hare system? No, in the last part, well, I think that you mean the sequential pairwise voting, right? So, yes, so it is definitely different than Hare. So in case of Hare, you need to do plurality voting for all candidates and just delete the, someone who has the first vote. But okay, so yeah, it is definitely different. So in case of sequential pairwise voting, so for example, say that we have the A, B, C, D, E as your candidate. Then if you want to sequential preference voting on this order, then it means that first just find winner between E and B, like Condorcet method, and find winner between the winner of the E and B and winner C, and again find winner between the winner of this this tournament and A, and lastly just compare the winner of our tournament with the last one, right? So that's sequential pairwise voting. So in our example in WebAssign, so you can find winner using the method you learned from the Condorcet method. So in the Condorcet method, you just compare both who prefer A to B and both who prefer A to B to A, right? Oh, sorry. So likewise, you can just find votes for prefer A to B and votes for B, votes who prefer B to C, B to A, then compare it and just determine winner, right? So let's deal with some example. So here in the WebAssign program, winner from, I just asked you to find the winner from sequential pairwise voting with order B, A, C, right? Then first of all, what you need to do is just compare B and A, right? And from the preference list, you know, ABC means that it's just, yes, it is just like a bracket system. So just first two be compared, and the winner of the first two is compared to the next next candidate, and the winner of that can also compared to the next one, and so on. Yes. So. Oh, okay. So here, yeah. So first of all, what you need to do is just compare B and A, and from the Condorcet's method, as you can see in the previous calculation, you can figure out that 13 people prefer A to B and 16 people prefer B to A. So definitely B beats the A, right? Yes, you can use the Condorcet method result to find the sequential periodic voting answer. Definitely, yeah, that's correct. So usually, if the problem and contains Condorcet method and sequential periodic voting method, then you can use the result on Condorcet method to determine sequential voting winner. Great. So here, from the Condorcet method result, we know that B wins, and then what we need to do is just compare B and C. But again, in this case, B also wins C, right? From the Condorcet winner method. So here C is the, so here B is also the winner in sequential pairwise voting in this case. Right. So it is not I mentioned in the course because it's a little bit advanced, but usually the if Condorcet method winner, if Condorcet winner exists, then it is also sequential pairwise voting winner. And if you think that why this one holds, it is completely trivial because, yeah, Condorcet winner means that if he just duel with another candidate in 1-to-1, he always beat others, right? That's the meaning of Condorcet winner. And then in the sequential pairwise voting, what he did to do is just comparing with another candidate in 1-to-1, right? So definitely the winner on Condorcet method beats every other candidate in sequential voting, no matter how this order changes, right? So usually Condorcet winner always the sequentially pairwise voting winner. But if there is no sequentially pairwise voting winner, then it depends on the order. So for example, think about the case this. So B beats A, but C beats, yes, that's what I want to explain right now. So C beats B, but A beats C. So in that case, no Condorcet winner, right? Because it is kind of rock, scissors, paper, right? So in this case, if it now order matters, right? So if our order is A, B, C, then B beats A. So here you can bet B on first tournament, and but B to C, you can C beats B. So the winner is C in the order A, B, C. But in the order C, A, B, then from C, the duel between C and A will win because A beats C, but duel between A and B wins, right? So here, B wins, right? So if there are no Condorcet winner, then definitely it is depending on order. So what you need to do is just compare each one, be careful, right? So it is kind of generalization of rock, scissors, paper, right? So if you just compare rock and scissors first, then definitely rock wins. Then if you compare rock with paper, then paper wins. But if you compare scissors and paper first, then scissors wins. Then if you compare it with rock, then rock wins, right? So the order matters if there is in contest winner. That's correct, Abigail, yes. Do you have any question on sequential pairwise voting or any other things on voting method? So if you feel comfortable with the number 1, then definitely you don't have any problem on solving, voting method question, especially calculating the winner or calculating the votes which candidate get. But another question about the voting method is number 2, and I just want to share screen. So in number 2, which voting method requires a preference with ballot? Choose or such method. And for this, definitely you know that plurality voting and majority rule doesn't require the preference with ballot because they only require the first preference, right? But in case of the voter count, definitely you know which candidate was which rank, right? To calculate the voter count. And in case of sequential pairwise voting, you also need to know which candidate is much more preferable than which other candidates for not only the first rank, but also other rank. Otherwise, you cannot compare each rank, each candidate in sequentially. And in the Hare system, also, you need to know how if some candidates who prefer the first rank most, if their candidate was out of the round, then you need to know what is their second option, right? So that's why pre-Hare system needs a preference list ballot. And definitely in the conversion method, you need to know the preference list ballot to compare every other candidate, right? For 1-to-1. So Rinji asks me that for here, if one letter is eliminated in round 1, wouldn't it have 0 votes in the second round? Yes. What I mean is this kind of situation. So, okay, think about this. So A got 11 votes, B got 10 votes, C got 9 votes, D got 8 votes, right? So in that case, in the first round, D should be eliminated. So in the second round, we need to just vote again for A, B, C, right?
Are we
But
supposed
then,
to be seeing something?
pardon?
Are we supposed to be seeing something?
Oh, no, you don't need to say something. So
No.
you can say something. Yes, please say. Yes.
No,
Sorry.
no, no. I just couldn't see what you were drawing.
Ah, okay. That's what. Okay, so that's what I share. Can you see it right now?
Yes.
Okay, great. So yeah, what I mean is that in case of Hare system, if we already know about the who is the first rank for each voters, then so in case A got 11 votes on the first rank, and B got 10 votes on the first rank, C got 9 votes on the first rank, and D got 8 votes on the first rank, then D should be eliminated in the Hare system, right? But what we want to also know is that how these 8 votes will be distributed to A, B, C, right? So if someone in these 8 votes, maybe there are someone whose preference list is DABC, or whose preference list is DBCA, or whose preference list is DCAB. And actually there are much more than here, but so what we need to know is what is the second rank for someone who thinks that D is the first rank, right? To deal with Hare system. So that's why we need preference with ballot, even if one letter is eliminated in round 1. Definitely D should get 0 votes in the round 2. But still we need preference list. Does it make sense, Minji? Does it answer your question or? Oh, in the WebAssign, okay. In the WebAssign, the eliminated one is B. So okay, actually, I just think that this is DNE because B is not even in the round 2. But yeah, so you can think it 0. So in the exam, I will definitely consider 0 as the same as DNE. So don't worry too much about that. Yeah. Okay. Do you have any other question on voting method? So usually all the questions are either multiple choice or short answers. So in case of short answer, I just say that if there is no winner, then just put DNE or something like that. But in case of multiple choice, definitely there is some options for there are no winners or something like that. Great. Okay. Do you have any other question? Okay, then let's deal with some paradoxes in the voting method. So first one says that the blank occurs when a state loses a seat as a result of an increase in the house size. And it is called Alabama paradox because that is what happened when Alabama turns out to be a state of the United States, right? So they actually, what I mean is that Alabama state representative of state Alabama actually has a problem on losing their seats. So that's why it is called Alabama paradox. So, so it is about the increasing house size, but if there is no change in the state population, but increasing house size gives some losing seats on some states, right? So that's Alabama paradox. And the next one is occur that seat number of seats fixed, the number of seats is fixed, and the reapportionment causes a state lose a seat to another state, even if their percentage of increased population is greater than the other. So this is the kind of situation that, okay, I'll share my screen again. So it is kind of situation that, so there are California in here, Texas in here, and any other states here, but population increase of California is 15%, and population increase in Texas is 10%. But by reapportionment, you know, California loses seats, but Texas wins seats. So it happens in the Hamilton method. So in this kind of thing, it's called population paradox. So that is the definition of the population paradox. Okay. So, okay, in the next one, the blank occurs in a reapportionment in which an increase in total number of states causes a shift of apportionment of existing states. So increase the total number of states means that there are new states came here. So definitely it is called new state paradox. And the blank says that the number assigned to each represented unit must be the standard quarter Q rounded up or rounded down. So it means quarter condition. So in case of, division method, there are some states who got more than one seed, which is more than one quarter, right? But so that's why we said that quarter condition is violated by the Webster method, Hill-Huntington method, and Jefferson method. And those are called all divisor method, right? But those paradoxes are free from all those divisors methods, right? Only Hamilton method has such a paradoxes, and that's why current United States House chooses Hill-Huntington method instead of the Hamilton method. But yeah, so that also should be remembered for you for exam, right? Okay, do you have any question on paradoxes and method? And before going further, I just want you to know the comparison between each method. So definitely Hamilton method is not a division method. So we know that Jefferson method and Webster's method and here Huntington method, right? So these are called division method, and this it is called Hamilton method. But in case of Hamilton method, it rounds down, right? So okay. Hamilton method rounds down the quarter. And in which method also rounds down? Do you have, is anyone who remember this?
The Jefferson's method, right?
Thank you. Yes, Jefferson method. Thank you, Dawson and Dave. So Jefferson method and Hamilton's method, that also rounds down, right? But Webster method, it is not rounding down, but it depends on whether it is just, if your quarter is greater than 0.5, then round up. If it is greater than or equal to 0.5, then round up, but your pressure is less than 5, which means that you need to put the nearest integer on the quarter, right? And here Huntington method, it depends on the geometric mean Q star, right? So here Q star is just square root of the rounding down of Q times rounding up of Q, right? So if your Q is less than Q star, then round down. But if your Q is greater than or equal to Q star, then round up, right? Actually, that's what I explained badly in the class time. So I just want to emphasize it again. So that's the Hill-Huntington method, right? So that's the basic difference between those methods. So first case is first measure for differences is what is the division method and what is not the division method. As you can see, Jefferson, Webster, Hill-Huntington method are division method, but Hamilton is not. And second one is the range of rounding, right? So Hamilton method and Jefferson method, they always round down your quarter, but Webster method is finding the nearest integer, and Hill-Huntington method is using Q star to rounding up or rounding down. And this Q star is just square root of the rounding down of your quarter times rounding up of your quarter. So for example, if your Q is 10.278 something, then your Q star should be square root of the rounding down of your Q, which is 10, times rounding up of your Q, which is 11, right? Then you can get some number. Okay. Is there any other question? Okay, then let's deal with number 4. So suppose that Texas has 4 towns, A, B, C, D, and population is A has 59, B has 83, C has 27, and D has 16, right? Then also States gives them 37 computers, right? For free. And we need to use apportionment method described below to distribute these computers, right? And what you need to do is first finding the standard divisor first for any method. Yeah. And standard divisor is just population over number of seats, or in this case, number of computers, right? So if you add all those numbers, oh, sorry. I just show my writing. Okay. So if you add all those numbers using calculator, then 59 plus 83 plus 27 plus 16 is 117. And you need to divide it by 37. Then what you can find is 5. Right? So standard divisor is 5. Then you need to find Q, or quarter. And quarter is just dividing your number, dividing the population by the standard divisor. So quarter is population of each town by standard divisor. So here it is 59 over 5, which is 11.8. And in case of B, it is 83 dividing by 5, which gives you 16.6. And quarter of C is 27 divided by 5, so which gives you 5.4. And quarter D is 16 divided by 5, so it is 3.2, right? So that's the basic calculation for every method. Okay, do you have any question on calculating this quarter and standard divisor? Okay, then let's deal with Hamilton method first. So in case of Hamilton method, So rounded Q is just rounding down, right? So here, rounding down, you can get 11, 16, 5, 3, right? In Hamilton method. And if you add all those numbers, then 27 plus 10, which is 13.7, right? Oh, no, 27, 32, 35, sorry, 35, yeah. So we still have 2 more computers which we transferred. Then in case of Hamilton method, what you need to do is just comparing the fractional part of your quarter. So here, 0.8 is greatest among all other fractional parts, right? And 0.6 is the next greatest number among all other fractional parts because 0.4 or 0.2 is not the greatest part. So you need to add +1 on stage A and +1 on town B. Then the final apportionment should be final apportionment should be 12, 17, 5, 3 for if we use Hamilton apportionment. Right? Okay. Do you have any question? So one thing you need to remember is that in case of the Hamiltonian apportionment, their question. Minji says that you add it to those because they have the highest decimal right. Yes. So in case of the Hamilton apportionment, the state only get 1 more additional seats only, which means that they didn't get 2 more additional seats in any possible cases, right? So that's why we say the Hamiltonian apportionment always follow the quarter condition. So if we just choose, for example, in our case, if we think that A has the greatest fractional part, then A will only get 1 more computer. And in the next round, A will not be considered as the another one, right? Because we already considered it. If it was too high, would you subtract from the highest decimal too? Well, we will not have any question like this. What you mean about the too high?
I think she mean, oh, okay.
Oh my God, sorry for my. Can you still see? Can you hear me?
Yes.
Oh, sorry. Yeah. Okay. Could you ask me your question again, please? Yeah, sorry.
I think she's asking if, for instance, if we need 37 computers and we end up with like 39, what do we do then?
In case of Hamilton case, it cannot be happen because we already round it down. Yeah. We are still on Hamilton. Yes. Okay. So, okay, then let's go to the Jefferson method. So I will just copy this one because I don't want to write it again. So now we are going to choose Jefferson method. So in the Jefferson method, what you need to do is to find the divisor, right? So in case of the Jefferson method, to find divisor, it means that you need to just divide your population by the quarter plus 1. So from here, the rounded quarter is again rounding down. So it is 11, 16, 5, 3. Then, okay. Then you can get your divisor. It is just 59 over 11 plus 1. And if you just calculate it using your calculator, it should be, oh, sorry. Give me a second. 4.9, 4.916666 something. So if you just rounding up to 4 decimal, then it is 4.917 or 9167. And the next one is A3 over 16 plus 1. And if you just calculate this number in your calculator, 16 plus 1 is 17. Then what you can get is 4.88235. 4.88235. So it is 4.8824 if you're rounding up to the 4 decimal. And likewise in C, it is 27 divided by 5 plus 1, which is 6. Then it is, if you just do it using calculator, then over 2, which is 4.5. And in the last case, if in case of divisor D, it is 16 dividing by 3 plus 1, but it is 16 dividing by 4, so it is 4, right? Then in case of Jefferson method, again, in the Jefferson method, it will not happen that the computer is, there are no more computers, so we need to reduce computer. Instead, in case of Jefferson method, also there should be remaining computer, right? So in that case, you need to choose the greatest divisor in here, then give them 1 computer, then adjust it in quarter is just 12, 16, 5, 3. Then you're also adjusting your divisor, di again. And for in this case, you know that only the number of computer of A changes. Every other things are same, so their divisor is also still same. So you can just write down their divisor. You don't need to calculate it again, but only you need to calculate the divisor on A again. So it is 59 over 12 plus 1. So in this case, 59 over 13 is 4. Oh, that's the rule for Jefferson method. So in case of Jefferson method, we need to add plus 1. So it is just avoiding when ni is 0. So when you record the example we did with, then there are some cases that their quarter is just 0. Then pi dividing by 0 doesn't make sense in the paper. So that's why they give plus 1 or plus 0.5 in case of the Webster method or something like that. And okay, anyway, this one should be 4.5384 something. So in this case, in this case, B has the greatest divisor, so we need to add +1 on here. So A will finally get 12, B will finally get 17, and 5, 3, and done. Right, so that's the Jefferson method. Okay, do you have any question?
Can you show us how that looks like on answering on WebAssign?
Oh, okay, yes. So in the WebAssign, you can see that in Jefferson method, new divisor for A should be this 409.9167, which is just the divisor we just firstly got. And new divisor for B is 4.8824. Actually, 88235 is much more correct, but I always require you to just, rounding up at the 4 decimals. So yeah, that's sure. And new divisor for C is 4.5, which is 27/6. And new divisor for D is 4, which is 16/4. Then according to the new divisor, A will have one additional computer, right? Because divisor for A is the greatest one, right? And then all other divisors are not changed, especially B, C, D, except A, right? So divisor on A should be changed because A got new computer, so it should be 59/12 plus 1, which means 59/13. So you got this 4.5384. And also if you compare all those divisors, then now B got the greatest divisor. So B will have one additional computer too. Then that's all for computer, right? Because if you add all the number, then you got 37. Does it make sense?
Yes.
Right? Okay, then let's deal with the Webster method. So here in the Webster's method, rounding Q, rounded Q is just rounding nearest integer. So instead of 11, it should be 12. And instead of 16, it should be 17. And 5 and 3 are just same because they are all fractional part, which is less than 0.5. And if you add all the number, you get 37, you are done. But that's the only good example. But to be preparing your exam, you need to remember the case when your rounded Q gives the more computer or much less computer. So for example, yeah, it's just example, think about that. We have A got 13 computer, B got, okay, so what kind of example is good? B got, B got still 17 computer, and C got 5, D got 3 computer in this case. And if you add all those numbers, then what you can get is 38, which is definitely greater than 37. Then your divisor should be your population over an I minus 0.5 instead of 1, or it should be minus 0.5, right? So, okay, yes. So it is also called DI minus. So in this case, A should be 59/13 minus 0.5, and B should be 83/17 minus 0.5, and C should be 27/5 minus 0.5, and D should be 16/3 minus 5.5, right? So that's one case. Yeah, when your apportionment gives the number which is greater than the allowed house size. But the other case is that, like the Hamilton or Jefferson, there are number of seats is still remaining, right? So for example, A, B, C, D still got 11, like Hamilton and Jefferson, 11, 16, 5, 3. Then in this case, they only apportion 35 seats, so 2 seats are remaining. So in this case, your new divisor should be, for example, DI plus, and it should be population over your apportion seats plus 0.5. So A should got 59 over 11 plus 0.5, which is 11.5. And B should be 83 over 16.5. And C should be 27 over 5.5. And D should got 16 over 3.5, right? Then in case of you use DI minus, then choose the least number, right? Choose the least divisor. But in case of you use DI plus, then choose the greatest divisor. Yes, we are still doing Webster, yes. I just want to deal with some general cases of Webster, because in the current example, yeah, you don't need to do such a thing, but then, yeah, if you choose the greatest or smallest divisor in each case, then give them 1 seat or get rid of 1 seat from them, then do the same round, right? Not the whole number of fraction, yes, Hannah. So in case of Hamilton, we already think about the fraction part, but in case of division method, you need to think about the whole fraction, whole number, not only fraction, but the whole number. So for example, if A got 5.7, B got 6.1, then definitely you need to choose B because the whole number is greater than 5.7, right? Yes. So that's the general cases of the Webster method. And if you just give them or get rid of 1 seat, then you need to calculate their divisor again and compare it again and choose the smallest one or greatest one in each cases, then you are done, right? Okay. Do you have any question on Webster method? Okay, and next we will go to Hill-Huntington method. Yes, this review will be posted to eCampus. So yeah, thank you for being here. But if you have any other schedule, then you can just repeat. Oh, sorry. Then you can see it again. I posted on YouTube and eCampus. Okay, so in case of Hill-Huntington method, what you need to do is find Q star first, right? So Q star is just number which is rounding down and rounding up, right? So it means that the Q star for this 11.8 is just square root of 11 times 12. And Q star for 16.6 is just square root of 16 times 17. And Q star for 5.4 is 5 square root of 5 times 6. And Q star for 3.2 is 3 square root of 3 times 4, right? And if you just calculate those numbers using your calculator, then it should be 11.4891. And this one is 16.4924. And this one is 5.4772. And this one should be 3.464 something. Then you can compare those numbers with the original quarter. So in case of A, the original quarter Q is greater than Q star. And in case of B, original quarter of B is greater than Q star. And in case of C, in this case, Q star is greater than C, or a quarter of C. And again, in case of D, Q star is greater than quarter of D. So for the first two cases, you need to rounding up. So I will get 12 computer, and B also will get 17 computer, which is just rounding up 11.8 and 16.6. But in the below two case, in this case, they are less than Q star. So you need to rounding down. So you get 5 and 3. Then if you add all the number, then what you can get is, this is the number of computer in here. So we are done, right? So this is the special case. But if, for example, if it is not this kind of number, so for example, if A got 13 points, B got 17, C5, D 3. So if we just distribute 38 computers, but the house size is already 37, then you need to find DI. But in this case, DI minus is your population over square root of what you already distributed times 13 minus 1, right? So for example, in case of A, it should be 59 over square root of 13 minus 1. And in case of 17, it is 83 over square root of 17 times 17 minus 1. In case of C, it should be 27 over square root of 5 times 5 minus 1. And in case of D, it should be 16 over square root of 3 times 3 minus 1, right? And like the Webster method, you need to choose the smallest D in this case, right? And give that and get rid of the computer from them, right? But in case of computer is, is actually there are some remaining computer, then you need to use DI plus. In that case, it is just PI over square root of NI times NI plus 1, which means that NI is just the computer which already given, and multiply NI plus 1 and taking square root. Then choose the, in this case, choose the greatest one. Then do the same thing on Webster method. Okay. Okay, do you have any question on here Huntington or Webster method? Okay, then let's get back to the cake problem and inheritance problem. Okay, so Jane and Mary will share the cake, and Jane is your divider and Mary is your chooser, who will get at least half of the cake. So think about the case. So if you know about this, think about the case that there is some cake and Jane divides like this. Then there are 2 portions of cake. Then who choose who one? Mary will choose B, right? Because B is the greatest portion. So if Jane divides badly, then always Mary can get at least half of them, right? Yeah, if you choose, then you get the first choice and you should get the bigger one, right? Yes. Yes, that's correct, Adil. So that's why in this problem, Jane and Mary will share cake, then Mary will get at least half of the cake, right? But Jane will get at most half of the cake when she cut the cake very precisely, right? Okay. Do you have any question on those cake questions? Okay, then let's go to the bakery auction case. So in case of bakery auction, what you need to remember is that definitely someone who bids the most get the item, but he will only pay the second most piece, the price of the second most piece, right? So in this case, Jane sold her patch of cake on eBay. It is not almost impossible, but anyway, so which uses the bakery auction. And Carrie bids $20, Tulsa bids $21, and Hamilton bids $32. So in this case, the bid who is the most is Hamilton. So Hamilton definitely winner of the auction, but Hamilton will only pay the second most bid, which means $21, right? So the Hamilton will pay only $21 instead of 32. That's bakery auction. Do you have any question on this? Okay, then let's go to the nested inheritance case. So this is what lots of you had questioned me before. So, okay, so here we have John and Mary, and John and Mary inherit their car and house. Then John bids $28,225 on the car and $55,900 on the house. And Mary will bid $32,100 on car and $59,100 on house, right? And we want to use nested inheritance method to distribute those items. So first of all, what you need to choose. Now I'm sharing my screen. What you need to choose is who is the winner on each case. So first of all, Mary's bid is greater than on John in car, and also her bid is greater than his bid on house. So Mary definitely wins on both cases. But yeah, so but in case of nested inheritance procedure, just do it case by case because otherwise you have some, some confusion. So in this case, N is 2, right? Because there are only 2 persons. So first of all, Mary will pay n minus 1 over n, which is 1 over 2 of her bid. So she needs to half of her bid. On holding account. Catherine, okay, in our notes, doesn't it say that nested method is used on more than 2 parties? Yeah, it can be used on more than 2 parties. It can be used on 33 or pro or any other party, but also it can be used on 2 parties also. Okay, thank you. Then first of all, John will get 1 over n, which is half of holding account, of his bid on from the holding account. So half of his bid is half of this 28225. So it is 14112.5 dollars. Then after that, in the holding account, yeah, it will only have 34.5. And I think that's correct, but okay, I just put it on the calculator to avoid mistake. Oh, 1937. Okay, sorry. 37.5. Yes. So in the remaining money should be this amount of money. And next, all participants share remaining money equally, right? So John will get half of this money, which is 968.75 also. So from the car, John will get this $102.5 plus $968.75 also, right? So that's what John will get, but what Mary will get is the car, and she needs to pay what John will get, right? So you don't need to, find Mary's case in the 2-person case, right? That's why I choose the 2-person case in the example. So in this case, you don't need to avoid some additional calculation. So if you add those numbers, then it should be 15081.25. Okay. Do you have any question on case of car? So Mary pays the exact same amount of money of John. Yes. So in case of the two-person case, you don't need to calculate Mary again because that's what Mary will pay. So yeah, no. Actually, in the first bank, you need to add the case of house, right? This is already case for car, so we need to calculate case of house also, right? So in case of house, again, you can do the same thing here. So John's bid is 55,900 and Mary's bid is 59,100. So here, first of all, John will get half, no, sorry. Mary will put n minus 1 over n, which is half of the 59,100, which is just this amount of dollar on holding account. And then John will get half, 1 over n, which is half. Sorry, my writing is bad. His bid, which is just half of the his bid, so it should be okay. There. So from this, in the holding account, the difference between those money, which is $1,600 in the holding account, and lastly, they share this remaining money. So John will get $800 also. So finally, John will get this $27,950 plus $800 on the house case, and Mary will pay what John will get. Right, and if you add those two numbers, then is 2,800,750. And if you add those numbers with the case of the car, then what you can get is this 43,831.25 dollars. So John will get such amount of money, and Mary will need to pay such amount of money instead of getting house and car, right? Okay, so these two, the same number is answer for two blanks in the number 6. Okay, do you have any question on number 6? Yes, Catherine, if it is 2 people, will it always be the same amount? So, because in case of 2 people, 1 people should pay some money, but 1 people should pay back, right? So, okay, do you have any other question? Okay, then let's deal with the division case. So it is actually exercise from the textbook. So yeah, okay, I just wanted to say that if you just want to prepare more, then please see the exercises in the textbook in the, so because in the exam, I've got a lot of examples from the exercises of textbook. So if you are familiar with those exercises, then definitely you are pretty fine, right? So okay, actually also this table is also came from the textbook. So this exercise illustrates how the adjustment procedure can be used to resolve dispute, right? So here, Mike and Phil are roommates in the Paris, and they encounter serious conflicts, so they want to, adjust their jobs in the room and on the issues, so to determine the decision. So here are issues. So okay, I just wanna put it in there my notes. So stereo level here, mic 4, period 22, smoking. So mic peer wins. Smoking rights 10, 20, room party police 50, 25. So here mic wins. Cleanliness 6, 3, and alcohol use 15, 15, and phone time 1 and 8, and lights out time 10, 2, and visitor police 4 and 5. And we want to use the adjustment procedure to resolve this dispute. And remember that, yeah, codes I give some problem in the quiz that just the other coach do this or something like, question, but I do not put any such kind of question in the exam. So you don't need to worry about that things. So what you need to do is just doing the adjustment procedure and determine who got which, right? So in this case, okay, give me a second. So in this case, in the stereo rebel, Peer wins, smoking rights, Peer wins, so Peer's heavy smoker maybe, and room party police, Mike wins, and in the cleanness, Mike wins. This is 3, not the 2. And in case of alcohol, they are tied, so let's just leave it. And in case of phone time, Phil wins, and in case of right child time, Mike wins. In case of visitor police, Phil wins, right? So if you see such a tie case, then just put it there and add all other things first. And if you add all other things, what Mike got is 50 plus 6 plus 10, which is 66, right? And if you add all the points Phil got, then it is 20 plus 22 plus 20 plus 8 plus 5. So it is 55, right? So here, without this alcohol issue, Phil is loser, right? So in that case, this tied case will be going to the initial loser without that, right? So this 15 should be added to Phil. So Phil got 70. So now Phil is the initial winner. Does it make sense? So that's the subtle point. So if you have some tied issue, then just give it to the someone who is initial loser to make yes, so that, yeah, make a kind of the, yeah, so that's the rule, right? Okay. Then P is the initial winner. So you need to choose the profit ratio, find profit ratio, or so profit ratio. So for stereo rubber, it is 22/4. It is 5 point something. And smoking right, it is 20/10. It is 2. And in case of alcohol, it is 15/15, which is 1. And in case of Fontaine, it is 8/1, which is 8. And in case of digital policy, it's 5/4. It is 1.25. So the risk profit ratio came from alcohol, right? So you need to use alcohol as a, you need to give some part of alcohol to the mic, right? But if you just give all alcohol case to the mic, then it changes initial loser and winner, right? If alcohol belongs to Mike, then Mike will get 66 plus 15, which is 81. But the field has 55 points, so initial winner is winner and loser will be changes, right? So instead of doing this, we can just make them agree for sharing those issues to get make them have the same points, right? So to do this, let's say Mike will get X of the alcohol issue. Then what will Mike get is this 50 points and 6 points from Krinis and 10 points from Reichapurish and 15 times X, right? But what Pierre will get is this 22 points plus 20 points plus this 15 times 1 minus X, because 1 minus X is what Pierre will get finally, plus 8 plus 5. And our objective is to make that they have the same points, right? So this equation should be the same as this equation, right? Okay, does it make sense before going further? Or do you have any question? Okay, Javier, go ahead.
So your equation is all of the numbers added up for Mike and then an X? I
Yeah,
mean,
X is the what Mike will get part of it, right?
Okay.
So 15 point times X is what we might get as a point in the alcohol case, right?
Because that's the tie one, right?
Yes, that's the tied one, yeah.
And then below for
Mhm.
Phil,
Mhm.
you add 1 minus X for Phil's numbers for his equation?
Yes, because yes, so what I did is just assume that the whole portion of alcohol is 1, right? Then if Mike will get X part of the alcohol, then all the remaining part, which is 1 minus X, will belongs to Pierre, right?
Right.
So that's why I multiply 1 minus X instead of the X, right?
All right. So why did we get the fractions earlier when you did Phil divided by Mike? What was that for?
Actually, this X is our fraction, and we want to know how to get such a fraction because we don't know at this point, right? So that's why we have such an equation first.
Okay.
So did I answer your question?
Yeah.
Okay, great. So then what you need to do is just solve all this equation. So 50 plus 6 plus 10 plus 15x is equal to 22 plus 20 plus 15, 1 minus x plus a plus 5. And if you add all the number, then it is 66 plus 15x is equal to 42 plus 50, 55 plus 15 minus 15x. So this number is 70 minus 15x, 66 plus 15x. So adding those two numbers, you get 30x is 17 minus 66. So 30x is 17 minus 66, which is 4. So x should be 4 over 30. So Mike will get 30% of alcohol. So it is, how much is it? It is 13.33% of alcohol, and Pierre will get 26 over 30, which is 86.66% of alcohol issue, right? Okay, so that's the case. So the answer should be Pierre is initial winner, and he will get stereo rubber here, smoking right here, and 86.66% of alcohol issue, and phone time and visitor. And Michael is the initial loser. He will get room party police, coolness, and 13.33% of alcohol-ish and light out-ish, right? So that's the answer in the website. Okay, do you have any question on the this adjusted police? Oh, okay, last part again. So what I did is just summarize all the things. So you understand that Mike will get this 30.33% of the alcohol issue, and he will get 86.66% of alcohol issue, right? Last part equation. So, okay, so what I did is just find this equation. So our objective is to make Mike and Phil have the same points so that there are no winner or a loser, right? Because we want to have a fair division. And to do this, we need to count the points Mike will get and points Phil will get, right? And point Mike will get is this 50%, 50 points, 6 points, and part of the 15 point and 10 points, right? But we don't know what part is yet at first, so I just put X as a part of alcohol belongs to Mike, right? So that's why equation for Mike as 50 plus 6 plus 10 plus 15X. And likewise, here we get 22 points from the stereo rubber, 20 points from smoking right, and part of alcohol which not belongs to Mike. So that's why we multiply 1 minus x instead of x. And phone time issue, which gives Pierre 8 points, here 8, and visitor issue, which will give Pierre 5 points, right? So that's all the points Phil will get, right? And what you want to do is just make their points equal so that there are no winner or no loser, right? So that's how I get this equation. Does it make sense, Linji? Great. So we add the shared value for loser, yes. But not only adding the shared value to the loser, we also need to, add the get rid of shared value from the winner. That's this 1 minus x part 2, right? Without this 1 minus x, actually still got full 15 points, right? But by multiplying 1 minus x, now Pyrrhic already got some parts which is not belongs to the loser, right? And then solve for x, yes. Great. Okay, do you have any other question? Okay, so I think that if you're familiar with this and still you want to prepare more, then as I said earlier, please see the textbook, especially the programs in the textbook exercises, because those are all I've got as an example. And then I think you're definitely fine. So good luck on exam. And one more thing, I already definitely emailed this for you, but your exam grade was not be seen in the WebAssign or eCampus by the first time. So it's because our course coordinator need to decide when we disclose the exam scores. So please be patient for a little bit days. And Linji, I have another question that, okay, I have another question, but on the 3 minus the last question, I missed what you explained. What is 3 minus? Question 3. Okay. You mean number 3, these paradox questions? This divisor method mean? Okay, yes. So the Jefferson and Webster Huron-Tyndall method called divisor method because they use it adjusting divisors, right? So that's just name of the methods. Yeah. Okay, is there another question? Okay, then thank you very much for listening this 2-hour-long review session, and I will post it on YouTube. And if you have any question, and feel free to email me. I think that I will be asleep at the 11 p.m. So until the 11 p.m., I will definitely answer all your questions as well as I can have. So good luck on exam 4, and thank you very much for taking my course. Okay.
Oh, really quickly, the Zoom that we joined for our exam, is it going to be this exact same one that we use for class?
Yes, you're right.
Okay.
Thank you, Karen.
Thank you.
And Elliot.